So in a three event probability, we're going to need three rows on our tree diagram. The nice thing about this one is though it's binary, so there's not three possibilities, only two possibilities. So the first flip would have this possibility. We have tails or heads. Okay. In the second flip, if we got tails, we can again get tails or heads. If we got heads the first time, we can get tails or heads. Okay, so this represents our event 1. Call that event 1. This would then represent event 2. Okay, and then for the third event, if we got tails, tails, we could have tails or heads. So there's tails, tails, tails. We follow the tree, okay, the branches on the tree, we get tails, 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 heads, tails, tails, tails. Okay, here we got tails, heads, we could get a tail or a head. Okay, so this represents one outcome. This represents another, this represents another, this represents another. We can have tails, heads here, tails, heads here. So there are 8 possible outcomes here. Okay, so this last row represents our third event of the combined 3 events. Okay, so we can see probabilities now. So if we said, what's the probability of getting heads 3 times in a row? Well, that would be this going down this branch. There's one possibility here. 3 tails in a row, there's this branch. There's one possibility here. So if we were to write the probability then, probability of 3 heads or 3 tails, well, there's 2 outcomes that we want, and there's 1, 2, 3, 4, there's 8 outcomes in total. So the probability is 2 out of 8 or 1/4 or 25%. So another way to show probability sample space is tables. And in fact, when we have 2 events, it's actually better to use a table. I think that's my personal opinion, but I think tables are better because they're nice and clean. They're much easier to keep track of. Okay, so this one here, we had 2 events, and we kind of drew in a tree, and it kind of looks a bit messy actually. But we can do a 2 event probability in a table better, especially when we have lots of outcomes. So that was 3 outcomes on that spinner problem. Okay, here we have 6 outcomes on each dice. Okay, so this is the one that you should have done an experiment on. So what's the probability of rolling 2 identical numbers in, or what's the probability of rolling a sum greater or equal to 7? Let's say also probability sum equals 7, because we did that one before in our experiment. Okay, and I think I told you that the probability is about 1 out of 6, and we'll see how the theoretical probability is 1 out of 6. So we can look at the 2 dice. I'm going to look at dice 1, and we're going to call that dice 1, and 1, 2, 3, 4, 5, 6 is our outcomes for dice 1. In dice 2, we have outcomes 1, 2, 3, 4, 5, and 6 as well. So inside our sample space, we have our sums. Okay, so if we got 1 and 1, we get 2. 1 and 2, we get 3, 4, 5, 6, 7. So I could write all my outcomes inside my sample space. So the black represents all the possible outcomes when we roll 2 dice. Okay, so 1 and 4 is going to give me 5. 2 and 4 is going to give me 6. Okay, red 3, green 4 is going to give me 7, 8, 9, 10, and then we just fill out our entire space like this. And you should notice that there is a pattern to this, right? Okay, and then so we have 7, 8, 9, 10, 11, 12. So let's actually just look at the first probability here as a probability sum of 7. So if I look at my sample space, these are all my 7s here. I can count them up. I've got 1, 2, 3, 4, 5, 6 7s. Okay, so the number of outcomes I want, there's 6 of them. And my sample space is a 6 by 6 grid, so there's going to be 36 possibilities. So this is where I got this probability of 1 over 6, because when you simplify that, that's 1 over 6, or about 16.6, about a little, just under 17%. So if you did enough dice rolls, you should have gotten that same result, okay, just about 17%. Okay, now you may not have done enough to get an accurate value, but again, the more dice rolls you do, the more closely your probability should, your experimental probability should reflect the theoretical probability that I've just generated in this sample space grid diagram. Okay, so let's answer the other problems here. What's the probability of rolling two identical numbers in a row? Well, two in a row are going to be these ones here. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So then the probability works out to be there are 6 that I'm looking for out of 36 total. So the probability of rolling a 1, 1, a doubles essentially, is going to be 6 out of 36. What about the next one here? What about the probability of rolling a sum greater than 7? So let me just get rid of this. A sum greater than 7. Okay, so all my sums greater than 7 kind of are in a pattern here. Greater than or equal to 7. So if I just highlight those ones, the sums greater than or equal to 7 are going to be represented along this side. Okay, so if I count them up, there's 6, 5, 4, 3, 2, 1. Okay, so what does that work out to be? 21. Okay, so it looks like there's 21 outcomes that I want. Okay, so the probability of sum greater than or equal to 7 is going to end up being, okay, there's 21 outcomes that I want, and there's 36 outcomes in total. So this is just under, about 60% or so. Okay, it's about 60%. Okay, so this is how we can work these things out. We can look at our sample space to get our theoretical probabilities. Okay, and this differs again from what we did at the very beginning here. Okay, when you did your table and your tally, your actual dice rolls were experimental, when we actually had to do some action to get some probabilities. All right, so in summarizing then, what are some two possible ways to show sample space in a probability experiment? What we can do is, and maybe I shouldn't call that a probability experiment because this is theoretical probability. So how do we show sample space? Okay, we show sample space 1 with a tree diagram. I'm just going to make a note here that this is great for 3 or more events. But when we have 2 events, like 2 dice, 2 coin flips, 2 spins, grid diagram is probably better. This is ideal for 2. Okay, so this is ideal for 2 events. Okay,